video is going to review right angle trig that you learned in Math 10 and show a few examples of what's going on. So right angle trig deals with right triangles, and the most important thing that you have to remember is that when we're dealing with trigonometry in grade 11, our calculators must be set in degree mode. So if you forget how to do that, just on your calculator, hit the mode button, which is right next to the second, and all these options should pop up. And what you need to do is go down to where it says radian and degrees, go over to degrees, hit enter, and now your calculator is in degree mode. So now you should be able to work properly within this unit. One of the biggest things that you should remember about right angle trig is this simple phrase that you probably were taught along the way, SOH. Now it is pretty simple, as I mentioned, but you have to understand what it's actually telling us. This SO is actually telling us sine of any angle is a relationship of the opposite side over the hypotenuse. Cosine of any angle in a right triangle is the ratio of the adjacent side in relation to the hypotenuse. And the tangent of any angle in a right triangle is a comparison of the opposite side and the adjacent side. So those three things, SOH, and then opposite hypotenuse, opposite adjacent, are absolutely critical in this unit. Now, what you have to remember, though, is that any right triangle should have those three sides in them. So here's a right triangle, and across from the right triangle is always the hypotenuse. Now you have to remember, how do I name the opposite side, and how do I name the adjacent side? Well, in order to do that, you need a reference angle first. So for right now, I'm just going to randomly choose this angle here as my reference angle. So if that's my reference angle, the side across from that becomes the opposite side. It's opposite from my reference angle. And the adjacent side becomes the one that's right beside it. So that's how we name our three triangles. So if I chose a different triangle and make it a right triangle, there's my 90-degree angle. So we should know across from that is my hypotenuse. And let's say I chose that angle up in the top left to be the reference angle. The side across from that, that's opposite that angle. And then this one's right beside it, so that's my adjacent. So you have to be very skilled in being able to name the sides of the triangle, otherwise you're going to run into some problems. So seeing as how this video is a review, we're going to jump right into doing some examples, and we won't be specifying exactly what we're using, sine, cosine, or tangent. We're going to have to decipher that information from our diagrams ourselves. So here's a right triangle, and you can see that we have an angle that is 48 degrees. We have a side that's 17 degrees. And we have this question mark along the way that we're going to try to figure out. That's what our unknown is. And we're going to use right angle trig to figure it out. First thing you probably want to do is label the sides that we're going to be using in here. This 48 degrees becomes my reference angle. That's the angle that we're going to use to solve this problem. Across from it is the side I'm trying to find. That's the opposite. And this guy is touching it, so this is the adjacent. So in here, I'm only using the opposite and the adjacent sides. The hypotenuse has nothing to do with this question right now. So if I think back to this initial little catchphrase, SOH, there's only one of those ratios that use opposite and adjacent, and it's this last one, TOA. So we start by saying, okay, the tangent of my reference angle, 48 degrees, is opposite over adjacent. Now we fill in some of the information that we do know. So we're going to keep the tan of 48. We're going to say the tan of 48 degrees is opposite over adjacent. Well, in my diagram, the opposite is the unknown. That's my question mark. And my adjacent was 17. Now from here, depending on the teacher you had and depending on how you learned it, you could take any step to solve this. The one that I like to use is cross multiplication, because a lot of you understand how cross multiplication works fairly well. So this on the left-hand side, tan 48, I can easily say, you know what, that's over 1. That won't change the fraction at all. So now I just need to cross multiply to figure out what the question mark is. To cross multiply, we simply say, okay, 17 multiplied by the tan of 48 degrees divided by 1 will get me the answer I'm looking for. Now the divided by 1 in this situation isn't that important because dividing by 1 does not change our value. But if in our calculator now we go to do this, I'll show you the simple way to make sure your calculator, you're keying it in correctly. All we have to do is say 17 times the tan of 48 degrees, close the bracket, get in a good habit of that. We can say right now divided by 1 if we wanted to, but we know that, as we mentioned already, that operation will not change my answer. So basically 17 times the tan of 48, that side is approximately, let's say to 1 decimal place, 18.9 centimeters long. So we used the tangent ratio to find that missing side. So now let's look at another example that we can use sine, cosine, or tangent to find an unknown sine as well. So here's a right triangle. We have an angle of 21 degrees. We have a hypotenuse, because it's across from the right angle, a hypotenuse of 5,432 kilometers, and we're trying to find this side x on the bottom, and since that's touching my reference angle, which is 21, that becomes my adjacent side. And again, we should think back to TOA and say, okay, according to what I have labeled here, I need to use the hypotenuse and I'm trying to find the adjacent side. Adjacent and hypotenuse, well, that works out to be cosine. So in this question, we're going to use the cosine of 21 degrees, because that's my reference angle, is adjacent over hypotenuse. And we substitute in some things that we need. So the cosine of 21 degrees, the adjacent is my x, the hypotenuse is 5,432, and we're going to cross multiply again to figure out what the missing value is. We put this over 1, and we get x equals 5,432 multiplied by the cosine of 21 degrees divided by 1, which won't make a difference for us in this question again. And so we could try that in our calculator once again. 5,432 multiplied by the cosine of 21. Get in the habit of closing that bracket. Enter. Again to 1 decimal place. We'll say 5,071.2 kilometers. So 5,071.2 kilometers is the measure of x. Now, if you were doing this question on your own, you should be able to at least realize that your answer is reasonable. The way we can identify it as being reasonable, we don't know if it's really right or not if you're doing it on your own, is to say, well, if my hypotenuse is 5,400 kilometers roughly, I know that a hypotenuse has to be the longest side in a triangle. As long as this side that I found is shorter than that, my answer is at least reasonable. So you should always be checking for reasonableness at the end of every problem you do. The next 2 examples we're going to do are going to focus on using trig to find an unknown angle. So here I have a triangle, ABC, and my instruction is saying, you know what, try to find angle A. So this right here is the angle I'm looking for, and by default that becomes my reference angle. So I go and I label my sides of my triangle according to that reference angle. So if this is angle A over here, this is the hypotenuse, it's across from the right angle. And 15 is across from my reference angle, so that's my opposite. So again, examine SOH and figure out which 2 sides we're using, opposite and hypotenuse. So now this is a sine ratio question. So write it down. We're going to say the sine of angle A equals the opposite side divided by the hypotenuse. And we fill in the information we have. The sine of angle A equals the opposite side, 15, divided by the hypotenuse, 28. Now, when we're finding an angle, we never have to cross multiply. For angles right now in sine, cosine, tangent, just right angle trig, we have to use the inverse sign. The inverse sign is denoted by this. So if I take the inverse sign of 1528, 15/28, this will tell me angle A. So in your calculator, to find the inverse sine function, it's right above the sine button. So you have to hit the second function button first, sine, and then say 15 divided by 28. Get in the habit of closing that bracket, hit enter, and we usually round decimals to the nearest degree. So in this question, we could say angle A is 32 degrees, roughly. An extension to this would be able to find angle B. If I found two angles in a triangle, we know that all the angles of any triangle have to add up to 180 degrees. So if I took 180, subtract the 90-degree angle that's already there, subtract the 32-degree angle that I found, this will tell me what angle B is. So 180 minus 90 minus 32, that would tell me that angle B is 58 degrees. Now the question didn't ask for that, but it's a good thing to realize that whenever you have two angles in a triangle, you automatically know the third one with one quick calculation. The last example we're going to do is another angle finding question, and in here it says, in this triangle MIT, find angle T. So again, we could easily start by saying angle T has to be my reference angle. If that's my reference angle, let's label the sides that we know in accordance to that. So if that's it, across from here, that's my opposite. This side becomes my adjacent because the hypotenuse is the other one. So these two sides now, if we look once again at SOH and examine where opposite and adjacent fit in, that's my tan ratio. So now we're going to say the tan of angle T is opposite over adjacent. The tan of angle T, we fill in the information we need. Opposite is 14,321 kilometers. The adjacent is 2,135.4 kilometers. And again, since we're finding an angle, we don't cross multiply. We simply take the inverse tan. So we say the inverse tan of 14,321 divided by 2135.4 will tell me angle T. So now just go to your calculator and take the inverse tan of 14,321 divided by 2,135.4. Close that bracket, hit enter, and if you're in degrees, we should get this 81.5. But like we said, we usually round degrees to the nearest degree. So we'll say roughly, approximately, that's what that dot means. 82 degrees is angle T. And remember, if you have angle T, you already know what angle I should be. It would just be 180 minus this 82 minus the 90 that's already there, and that would give you angle I. The question's not asking for that, but just remember, once you know two angles, you definitely know the third. So that's reviewing trig. Remember, to find a side, we cross multiply. To find an angle, we take the inverse trig ratio.